this is the, well, welcome to start with. And my name's Chris Whitaker. I'm the development manager, the software development manager for the Elastic Beanstalk team and for the CloudFormation team. And this presentation is really kind of a follow-on from the presentation Evan did this morning in this same room. So it kind of follows on from that and goes into more detail about other things you can do with Elastic Beanstalk. Let's find the clicker. There we go. So the good news is you don't have to listen to me for an hour. We have Sahindra and Pengchao from ThoughtWorks, and they're going to talk about an interesting application tool that they built on top of Elastic Beanstalk that makes it easier to deploy and manage applications on top of Elastic Beanstalk. And so I'll hand it over to them about halfway through. So what are we going to talk about? So we have a few things to talk about. So we're going to talk about kind of how to control the lifetime of AWS resources relative to the application itself. So for example, you may have your application deployed. You may have a database you want to deploy. But you may want the database to last longer than the application itself. And we'll talk about how to do that. Then we're going to talk about how to extend Elastic Beanstalk. So we give you a specific set of resources when you create an environment. And we're going to talk about how to add other resources to that configuration. And then we're going to talk a little bit about how you might control the traffic to your application as you do a deployment. So how to do zero downtime deployments, things like that. On full disclosure, I'm going to assume that you guys all know about Elastic Beanstalk, so I'm not going to do anything about introduction to Elastic Beanstalk. I'm just going to assume you guys know that. I'm going to walk through a few scenarios and how you would deploy, how you would use those, deploy those, so that you can get an application up and running. And then we'll hear from the ThoughtWorks guys. And then at the end, we'll do a Q&A session, time permitting. If not, we'll certainly be outside. So let's talk about controlling the lifetime of resources. So the key takeaway for Beanstalk environments is we'll create a whole bunch of resources on your behalf. So if you create an auto-scaled load-balanced Beanstalk environment, we'll create a load balancer, we'll create an auto-scaling group, a bunch of other resources. All those are created as a single unit and managed as a single unit. So anything in that environment has the same lifetime. So if you create that environment, all those resources will be created. If you terminate that environment, all of those resources will be deleted. If you do a rebuild, then we actually tear down all of those resources and rebuild all of those resources. So why is that important? Elastic Beanstalk supports RDS out of the box. So you can click in the console and say, I want a database associated with this environment. Or in the EB tool, you can say, yes, I want an RDS database. We'll actually create an RDS database for you during that environment creation. But the lifetime of that database is tied to that environment. So if you terminate that environment, the database will go away. If you rebuild that environment, we'll tear down the database and bring up a new one. You can create snapshot of the data when we delete it. So you can save the data. But the new environment that comes up if you do a rebuild is not going to have that data in it. So there's a couple of ways you can get around that. It works well for kind of dev test environments where you actually do want a clean database every time you spin up that environment. For production, that may be not what you want because you may have interesting data, kind of the crown jewel data inside that database. You actually need that database to keep running after the environment's terminated. So you got a couple of ways. One is obviously you can go to the console, create an RDS database in the RDS console, link it up to the Beanstalk environment. The other way, and we'll talk a little bit about it, is to use CloudFormation to manage the resources which have different lifetimes independently. For those that don't know what CloudFormation is, it's really just, one of the AWS services that provides a way to create a set of resources as a single unit and manage them as a single unit. And so in this case, we'll create a Beanstalk application and a database in a CloudFormation stack. I won't talk too much about CloudFormation. There was a talk last year on kind of intro to CloudFormation. That's on YouTube for the reInvent YouTube channel. And there were a couple of CloudFormation talks during this reInvent. So if you want to learn more about CloudFormation, they're definitely good resources to look at. So let's dig into that a little bit more. So this is my application. I have an environment running, I have an ELB, my app's running on a load balance, on an auto-scaling group, and I have a database, and that database was created as part of this environment. So it's within the box that indicates the environment. If I terminate that environment, we're going to blow all that away. So the database is going to be terminated. If you rebuild that environment, we'll terminate the database and bring a new one up. For production environments where you actually want to keep that database, then we really want to take that database out of the environment. So this diagram kind of describes that, where now I have the environment, it just contains the load balancer and the auto-scaling group and some of the other resources in that environment, but the database is pulled out of it. So now when I terminate that environment, we'll just terminate the Elastic Beanstalk environment itself, and the database will be kept running. So I'll just flip to kind of give you a, maybe. There we go. Or not. Yeah. Maybe we won't look at the template. We'll skip on from that, but essentially I can give you guys a CloudFormation template. That will be visible. We'll give that to you guys. Really, a CloudFormation template is a JSON file. It contains the set of resources that you want to create during that. See if we can get back to that. That's fine. Yeah, we're good. So it's really a JSON file. It contains the set of resources that I want to create. And when you see that template, you'll see that there's a database, a bunch of security groups, and an Elastic Beanstalk application. They're defined in that template. When I use CloudFormation to create that stack, we'll create all of those resources. Now I can terminate or rebuild that environment, and the database will not be touched at all. So we talked kind of about how you add RDS databases to that environment, but there may be other resources that you want to add. So Elastic Beanstalk out the box gives you a couple of different configurations. So you have load balanced auto-scaled configurations. So that's a load balancer, an auto-scaling group, a bunch of security groups, things like that. We also support a single instance environment. And so that's a single instance with an EIP. Mostly used for kind of dev test environments where you don't need the load balancer, you only have a single instance. And then we support RDS databases. But what if you want to add other resources? So for example, I want to add an Elastic Cache cluster or a DynamoDB table to keep session state, or I want to add specific CloudWatch alarms so that I can monitor my application that are created as part of that environment. So you got a couple of options. We talked a little bit about CloudFormation, so that's definitely one option. But Elastic Beanstalk has a way to extend Elastic Beanstalk environments. And like it says on the slide, the resources that you create as part of the EB extensions are actually have the same lifetime as the environment. So for example, if I want to create an alarm that is specific to this environment, I can put it in the extension, and it will be torn down when the environment's torn down, everything will be cleaned up just fine. So how do you actually add resources using extensions? So the way we think about extensions is they're really dependencies that the application has, just like packages and files that you deploy to the environment. And so what we did was say, well, I want to keep those with the application. And so the way you do that is to create configuration files that are part of the application package itself. And they go in a special directory, EB extensions. You can have as many config files in there as you want. When you create that environment, Elastic Beanstalk pulls down those extensions and adds them into whatever the environment is. So if I want to add an EBS volume to my environment, I can add those. If I want to create alarms, I can add those. all defined in the configuration files. So let's look a bit more deeply at a configuration file. So a configuration file is really just, it's a YAML file. And in that file, you can specify option settings. So you can configure various attributes of the different resources that are in the Elastic Beanstalk environment, and we'll go into that in a little bit. I can also add resources into that configuration file. So if I want to add an alarm, I need an SNS topic and I need an alarm, I can add those resources into the config file. When you create that environment then, it'll take those option settings, apply those to the environment, and it'll add the additional resources into your Elastic Beanstalk environment. So let's look specifically about, I want to add an EBS volume to my environment. EBS is actually directly, EBS volumes are actually directly supported by Beanstalk itself, kind of like RDS. And you can enable them by setting particular option settings. So in the configuration file, I can have an option settings section. That option settings section, within that, you have different namespaces for different pieces of the environment. In this case, I actually want to change the launch configuration. I want to be able to say, well, I really want an M1 large instance type. And I want to attach an EBS volume to each instance that is spun up. And so I can do that through block device mappings. Auto-scaling supports block device mappings to allow you to attach EBS volumes during instance creation. So each instance in this case will get a 100 gig volume that will be attached to dev SDJ in a Linux world. If I want to add additional resources, I can also add resources in the resources section of the configuration file. So in this case, I want to create an alarm, which means I need an SNS topic to actually send that notification to. So within that, I can define what that topic should look like. In this case, it's an SNS topic, and it has a bunch of properties, one of which is what protocol to use to send the notification, in this case, email, and then where to send that email, which is the endpoint in this configuration. Within a configuration, you can reference other option settings. So for example, in this example, the alarm email address is actually taken from one of the other option settings. And you can default the value. So if you didn't specify a value for alarm email, then it'll get sent to nobody@amazon.com. So that's kind of a way to add other resources to your environment and be able to access other option settings to configure those particular resources. I then need the alarm. So in this case, I'm creating a CloudWatch alarm. It's a CPU alarm, so it has EC2 namespace, CPU utilization, it's the average. I want a period of 300, evaluation period, and so forth. But I want to actually have the aggregate across the auto-scaling group. So CloudWatch allows you to do that by what it calls dimensions. And one of the dimensions you can specify to an alarm is the auto-scaling group name. So we need to put that into the configuration in order to get the aggregate alarm. The way you can do that within the EB extensions is I can reference other resources that are in that configuration. So in this case, I need the auto-scaling group name. And so you can see there that there's a reference to the AWS auto-scaling group. That's the group that Elastic Beanstalk created in order to run this environment. So you can reference the resources that Beanstalk created within configuration. Just as kind of a reference, here are the list of the names of resources that Elastic Beanstalk creates that you can reference in configuration files. So you got the auto-scaling group, the launch configuration. We give you the environment name if you need the environment name, the load balance of the database, the security group. So you can get the names or any of the other attributes of those resources and apply those in your own configuration to extend the Elastic Beanstalk environment. So that's kind of how to extend Elastic Beanstalk to include other resources. So let's kind of move on to how you might think about deploying to Elastic Beanstalk environments. We'll talk about a few different things. So we'll talk about how to use Git branches to be able to deploy an application, maybe a production environment and a QA environment using the same repo, and how you would manage and control that. We'll then talk about how to do zero downtime deployments using CNAME flips, and that works even if the environment's under heavy load. CNAME flip is kind of an all or nothing. All the traffic moves from one place to another. And so at the end there, we'll talk a little bit about how you might control the traffic in a little bit more finer grain so that I can move traffic over time and not have a complete flip from one thing to the other. So branches, let's talk about branches. So the goal is that I have production environment, I have a QA environment. They're all the same source code, but different versions of that. I want to use a single Git repository in order to maintain and manage that application source. And so I can have a single Git repo, and you can associate different branches in that Git repo with different environments, which means that I can then push branch 1 to, in this case, the blue environment, and branch 2 to the green environment. And we'll look at how to do that. So in this case, I'm using the command line as an example. So if we walk through this, so in this case, I'm initializing the Git repo. And then we're using the EB command. So that's the Elastic Beanstalk command line tool. So we need to initialize that. What that really does is say, for the master branch in this Git repository, which environment should we deploy it to? And with EB init, you can either specify an existing environment, or you can create a new environment, or you can specify the configuration for a new environment. In this case, I'm actually targeting an existing environment. But if you wanted to target a new environment, then after the EB init, you just do an EB start, and then using whatever the init configuration was, we'll fire up a Beanstalk application. Then I can go through the test deployment cycle. So I can add the source, edit the source, do git commits, and then do the git AWS push. That then pushes the Git repo up to whichever environment's been configured, in this case for the master branch. Once I'm happy with that, I'm going to cut a branch because that's now my production code. So I'm going to create a Git branch, in this case V1. I'm going to check it out just so that the default Git branch is the V1 branch. And then I need to associate that branch with another environment. So EB has an EB branch command. And just like the EB init command, it associates the current branch with an Elastic Beanstalk environment. So in this case, again, it's going to be associated with an existing one. But if I wanted to associate it with a new one, as soon as I've done the EB branch, I'd then do an EB start, which would start up that new environment. Once I've done that, I can then do a git push. That's going to push the V1 branch to the environment that I just registered. And now I have the code running in V1 for the production branch, and I have the master branch pushed out to the development environment. Now I can just flip between branches. So I can check out the master, edit the source, do a git AWS push. Now I can push back to the test environment, so I can continue my development cycle. Eventually, I might want to then create another branch, a V2 branch, for example. So I can do a git branch, a git checkout, and then I can do another EB branch. And I can associate that with the same environment as the V1 branch. And we keep that entire history, and we'll look at whichever branch you're in. We'll push that to whatever environment is configured. So I may push to the V2 branch, to my production environment, decide that that wasn't the right thing to do, flip back to the V1 branch and repush, and that'll repush the V1 branch to production. So it gives you a way to manage branches and be able to associate different environments with different branches. Let's talk about zero downtime deployment. So you can, as we just looked at, you can do a git AWS push to an existing environment. We just launched a feature earlier this week to do roll and upgrades to an existing environment. So you can roll a change through it and not just push that to all instances at the same time. But if you have a couple of additional requirements, I don't want any customer to be impacted by the push, and I want to be able to roll back quickly. Then CNAME swap's a potential way of doing that. So let's kind of walk through that. So I have my Elastic Beanstalk environment. It's up and running. It's attached to my URL, yourapp.com, and it's all configured and set up. And any customer data or any requests to that URL are going to get routed to my application. With CNAME flip, the goal is to be able to do zero downtime deployment. So the way we do that with CNAME flips is you create another environment, in this case a green environment, running potentially a different version of the application. So in this case, the blue environment's running V1, the green environment's running V2. In this case, the databases are outside of any particular environment, so it's okay to reference from both of the environments. Then I can do a CNAME flip. So now, with a simple command in the console, there's a button that says CNAME flip, and you get the option of what's the source, what's the destination. And so we'll actually flip the CNAME to the new branch, to the new environment. So now all user traffic is directed to the new environment. If for some reason we decide that that didn't work as expected, we still have the old environment there. So we can do a CNAME flip back. And now traffic will get routed back to the previous environment. So that gives you a way to do a deployment of a new version, still having the old version, and being able to flip back and forth if you need to. Once you're happy with the V2 version, obviously you can delete the V1 version, and then maybe in future have a V3 version and flip back and forth between those. So it kind of gives you a way to do zero downtime deployments with minimal customer impact. What if you, so the one thing about CNAME flip is, as you just saw, we completely flip the CNAME from one environment to another. That means that all new traffic that comes in is going to move to the new environment. Obviously, there'll be DNS TTLs that need to happen and things like that, but ultimately, all the new traffic will get to the new environment. What if we want to control that amount of traffic going to the new environment? So we're not comfortable flipping everything. We just want to flip some subset of it so that you can test the new environment before you actually flip it over. So we have, with EB extensions, I can create any resource. And so one of the resources that I can create is a Route 53 weighted record set. So Route 53 is Amazon's DNS service. And it has a mechanism where you can have multiple records on the same DNS entry, and you can weight those. So now what I can do is I can add an EB extension, which is add me a resource record to my environment. That resource record will be applied to whatever the DNS name is. And so now my application is linked to my DNS name. I can have multiple of those. So now I can start to control the traffic. So let's look at that a little bit. So in this case, I have the blue and green environments again. The blue one's running V1, the green one's running V2. And I'm currently set up so that all of the traffic's going to the green one. I have a weight of 100 on the blue one, the blue one. The weight for the blue one is 100. The weight for the green one is 0. So none of the traffic's going to flow to the green one. I can go into the Route 53 console and flip the weights in the console. So now I can put, say, a weight of 10 to the green environment, and 10 of 110 of the requests will be routed to the green environment. So now I have a way to kind of control the amount of traffic going to my new environment. Once I'm comfortable with that, I can flip away, essentially, from the blue one by flipping the weights to 100, 0, the other way around. So now I have all my traffic flowing to the green one, none of the traffic flowing to the blue one. We'll see if this works. I guess it's not going to. That's okay. Back to the slides. So this demo was is it's really the extension, and I'll give you guys the extension. It's really just a Route 53 record set definition that you put in the EB extension, and it uses a option setting to flip the weights. So you can either flip the weights through option settings, which means a deployment, or you can flip the weights through the Route 53 console. And so it gives you a way to control the traffic like that. Just as kind of a throw in there, because we now have the ability to put Route 53 entries into a Beanstalk application, Route 53 also has the notion of latency-based record sets. What that means is I can put Elastic Beanstalk environments in different regions, maybe US East 1, US West 1. And rather than set up a weighted record set, I can set up a latency-based record set. Now my traffic from my users will be routed to the nearest, by Route 53's definition of nearest, environment. So now I can have kind of a geo load-balanced Elastic Beanstalk application. I have two environments, and I have a latency-based record set in order to route traffic to the nearest entry. So that's kind of the extensions, the pieces we went through. We went through customizing the infrastructure, so you guys should look at EB extensions to be able to add additional resources or option settings to your Elastic Beanstalk environments. If you want to control the lifetime of resources independent of the environment itself, look at using CloudFormation and Beanstalk together. That kind of gives you a good way to automate creating environments, creating applications that you can control different pieces at different times. Use EB and Git to do deployments to multiple branches. And either use CNAME Flip or Amazon Route 53 configuration to manage those deployments. A few other things to look at. So the 0 to 60 AWS Elastic Beanstalk presentation that Evan did this morning, that's a good one to look at. It's kind of the precursor to this. And then there's a couple of CloudFormation sessions that are useful. So there's a 0 to 60 CloudFormation. That was this morning, I think, or yesterday. And then there's the AWS CloudFormation under the hood session, which is 5 o'clock today. There's also the session that we did last year on the introduction to CloudFormation for people that haven't used CloudFormation. And then come find me, the developer booth, whatever. I should be outside. So I'll hand over to Sahindra and Pengchao, and they can walk through the cool tools that they built on top.
Thank you, Chris, for that good introduction of Elastic Beanstalk. A little bit about myself. I'm Sudhindra. I have worked with ThoughtWorks for about 9 years. I found out that I like breaking things and then making them back and building them back. Recently, we have been involved in moving one of our applications that we work on called Mingo over to SaaS. And last year at AWS reInvent, actually, we learned from the CloudFormation session that that's the direction that we want to go, and we completely changed the way we are building cloud. And this year, we are here to talk about EB Deployer, a tool about Elastic Beanstalk.
I'm WPC from ThoughtWorks. We are on the same team. I have been in ThoughtWorks for 7, 8 years. And let's start. So today, our topic is going to be how do we do blue-green deployment on Elastic Beanstalk, our way to doing this. So from last year, we moved Mingo to AWS, and we started providing SaaS offering. And from this year, we start an interesting transition that trying to break Mingo from a monolithic application to some decoupled small services. And for all the new services we provision, we put it on Elastic Beanstalk. Why? Because it provides the software stack for us that we needed, and it provides all the scaling, monitoring, log archive, out of box.
Yeah, and we picked Elastic Beanstalk because of all the services that it provided. But we wanted to do more with Elastic Beanstalk and with our app. We really wanted to do more continuous deployment, continuous delivery kind of things. And we found that Elastic Beanstalk had all these things that you could do with it, but there could be more we could do with it. Like, for example, automating your deployments and taking them to the next level, automating your blue-green deployments. So we thought we could contribute, use Elastic Beanstalk APIs and build a tool, and we call it EB Deployer. It's open sourced. You can find it at this URL and go try to use it. And we're going to introduce you what EB Deployer does. EB Deployer essentially is a tool to allow you to take your stock application and put it on Elastic Beanstalk and do blue-green deployments without any effort on your part. So what are traditional blue-green deployments? Just an introduction. So consider that a typical app stack, which has a few EC2 machines, a queue, maybe a cache, and any other thing that you could include in your app. And let's say you have deployed a version N that is in production right now. Let's call it the blue app. What happens when you actually write new features, and then you want to deploy it and make sure that everything works, and then switch it over so that your customers can get to access the new features? So you write more code, build a new version of the app, and you deploy a parallel stack. Let's call it the green stack. It has the new version. Now you want to make sure that your deployment went through all the features that you wrote do make sense and they work. So what do? Usually, you do some testing, maybe manual, maybe somebody triggers a test. Somebody is involved in figuring out whether it works or not. Once you're satisfied with that, you do a manual CNAME switch or press a button somewhere which does a switch. And then all the customers are now using your latest and greatest features. Once you're done, once you're satisfied that this is stable and works for a while, you go and, sorry, 1 second. The clicker stopped, OK. And then you go and terminate the old instance, because then you don't want to pay for the stack and keep on maintaining that, right? So a lot of manual steps involved. So what does EB Deployer do?
So EB Deployer automated this whole process out of the box by removing all the manual steps. So same with before, when you do the deployment, you have blue and green environment, both active, both running parallelly. Instead of manually test it runs a smoke test that you config in your configuration and track whether the newly created environment is good or not. Once after that pass, it automatically swap the CNAME between this environment, and then come to the last part. Instead of terminating all the environment, it just leave it there, wait for the scale down to release the resources, and use it as a safe night for the whole deployment process. Means if there is anything like doesn't work, bad happened, didn't catch by the smoke test, you still have a chance just simply swap it back and recover from the disaster.
Yeah. And what do you need to do all this? Is just run one simple command. Let's say you are developing this beautiful app called JRuby Rails 4, and you have built features with it. You just package it as a var. We like binary packaging better. And then you give it to EB Deploy, and it will go ahead and figure out what needs to be done to get you to a blue-green state. There are some configurations that you will make before you start on this. And it's like you'll specify which region you want to deploy. You'll specify your AWS credentials and things like that. Nothing unusual for an AWS user. But it is as simple as this. And you run this over and over and over in your life, and then that gives you continuous deployment. It also includes, the configuration also includes a way to just run smoke tests. Here we are showing you an example of a simple curl. It just tests whether our app, which is a very simple Rails app, which is like a blog, shows hello world as its welcome page. So it's just doing a health check. But you can imagine putting here any kinds of tests, any shell script, any Selenium, Cucumber, any of the tests that you want, and smoke test the features that you're developing, right? We are actually going to switch to a demo, and I'll just tell you what will be included in the demo. We'll start from one application stack, then do an actual blue-green deployment. You will see the switch happen, the smoke test running. And then we'll build more features during the process, and then do another deployment, and you will see the switch happening again. And we'll show you a few details of where to go and look for whether the auto-scaling happened correctly or not. Okay? Let's watch the demo. So we have this one environment already. Let's call it dev A. Let's call it the blue one. So let's say we went and did some work. You ran the golden command. And a new environment came up, a new stack came up, and it is being deployed. Let's call it the green deployment. Now the green that it shows is Elastic Beanstalk knows that it is green. So we are now running smoke tests on a green stack. Once the smoke tests are successful, this could take time depending on how long your smoke tests take. Once the tests are successful, we do the CNAME switch. Health status is green, we do the CNAME switch. Now dev B is our golden environment. That is what all our users are hitting. And if you look at the details, here is where you would go and find out what happened to dev A, that it scaled down. So those numbers should go down because more and more users will start hitting your new dev B environment, and that is what is active. Now let's say over the course of the day you wrote more features, it's time to deploy again. What do? You just run the same command. And then it deploys to the old stack that we already had, just reuses whatever it had, and makes that inactive. It will always deploy to inactive. It will not touch your active stack till smoke tests are green and the CNAME switch has happened. So this is the typical lifecycle. Elastic Beanstalk gets provisioned again. We run the same things. Elastic Beanstalk will run its health check. This is the health check running green. Then smoke tests will run. That is what it is doing right now. And once smoke tests are successful, it will switch. And you will see that now dev A will become active. So it is inactive still because smoke tests are being run. And once everything is successful, everything is green, it switches the CNAME here. And you will see that dev A has become, there is no inactive tag in it. So dev A is now the active one. So we have swapped, and now dev A has become the green or the blue as you wanted, right? The new features have been deployed.
So EB Deployer also has some resource management functionalities that can make blue-green deployment easier to implement. So like Chris said, typically the resources provisioned from Elastic Beanstalk is this lifecycle is bounded to the specific environment. And this sometimes can make blue-green deployment much, much harder to implement. So think about the example for if you have RDS per environment, and then while you do the deployment, actually you need to sync up the changes between the database. That obviously not a trivial job to do. So with EB Deployer, the environment become a higher level concept, which glues the blue and the green Elastic Beanstalk environment together. With the similar naming convention, you can define a cloud formation stack, attach the lifecycle of that resources that are provisioned from that cloud formation stack to the whole higher level environment concept. So let's go through a concrete example of adding RDS to the deployment. So first thing you need to do, you need to define a cloud formation template. This is not a JSON format, it's just some pseudo code. At the bottom of the resource section of the template, you can see we're gonna provision 3 resources. The RDS path security group is a EC2 security group. RDS DB security group is a security group, say, only the RDS path security group can have access to this database. And the last one is the RDS database, which is the database instance itself. And we define two output values. RDS database configuration is just some connection information that is collected from the database instance. And the RDS path security group, which was mentioned, the EC2 security group that have access to the database. Then next step, you add resources section to EB deployer configuration. So first, you pointing the template to the template we just created, the my RDS.json, and then you can define outputs section, which is just a list of rules. How do we want to map those CloudFormation output values to Elastic Beanstalk option settings? So for example, we have two rules here. The RDS path security group, the security group we just mentioned, its value ARN can be mapped to auto-scaling launch configuration security groups, so that all the EC2 instance that started by Elastic Beanstalk has access to the database we just provisioned. And the next one is the RDS database configuration, which will be mapped to the environment. Environment variable of the application means it will be assigned to the runtime. In runtime, your application can fetch that, set up database connections. So we have a demo here. If you configure this, while you run the deploy with the same command, it will start creating the CloudFormation template, the CloudFormation stack by some naming conventions. The stack name will just be application name plus the environment name to keep it unique between applications. And it's creating. You can see it's creating the three resources we defined in the template. First is the EC2 security group. Then is the DB security group. The last one is the database instance itself. So provision the database instance is going to take a little bit longer than other resources. So we cut off the videos here. And the deploy will just continue after provision the resource stack. It will just start Elastic Beanstalk deployment. So everything is done. Our stack is in ready state. Yeah. Then next, please. Yeah. Oh.
Yeah. So that's what.
Go back. Yeah. So then after this, you can go to the Elastic Beanstalk console to check, like say, how the value is set to there. Yeah.
Yeah.
Okay. Next. So EB deployer also provides some interesting options to give you different deployment flavors. You can check. For example, the Phoenix mode. If you set this option to true, what it does, it will do a Phoenix server deployment. Means for any environment it's trying to deploy, it first terminated, then recreated the environment. This will make the deployment process a little bit longer, but the benefit you get is you will guarantee never accumulate any state in your Elastic Beanstalk configurations and any EC2 instance. So it can avoid a snowflake problem. Another thing you can tweak is like deployment strategy. So besides blue-green deployment, we also provide the in-place update, which means instead of keep two environment deploy alternatively between them, we just keep one environment and keep updating it. This will have downtime, probably not fit for any production environment, but for development environment, it is handy for saving costs and time.
So the reason we built EB deployer was so that we can integrate with our tool for deployments. We call that tool Go, and we'd use this for our daily deployments. Now, since the time we first started using EB deployer, it has gotten mature over time, and we have more and more confidence in the tool. So what is happening today is none of the developers are actually involved in figuring out when the deployment should go out. actually, till staging, everything is automatic, and then our release manager can figure out whether he wants to deploy it to production or not. Actually, on another microservice that we built, even the release manager is not involved in figuring it out. If everything goes well in staging, after a few hours, it automatically deploys to production, because we have so much confidence in the tool and the features and the testing that we are doing. Right, and what is the worst thing that could happen? What could happen is that smoke test would fail, and there would be no effect to the user. So essentially, whatever we do, we can just continue doing our work. And if smoke tests fail, we get an email, and we go and figure out what's going on. So EB deployer has really helped us get to a better state in continuous delivery. So our continuous deployment problem is solved, and we are getting better at delivering features more regularly. These days, we do multiple deployments a day to production, and our users just get new features every day. So why should you use EB deployer?
So what do we get out of the box from EB deployer? Well, blue-green deployment automated and safe blue-green deployment with smoke test. And it's a build pipeline friendly. You can put it into your automated deployment process very easily. And it's help you define shared resources between blue and the green environment, and have different deployment flavors that you choose.
Yeah. So treat this as a Christmas gift and use it. And tell us if you want to add more things, if you want to go and hack on EB deployer, make it fit for your needs, and send us a pull request. And you can find us on Twitter or on our ThoughtWorks emails. Thank you.
Thank you.